Skip Counting versus Skip Chanting by Jeff Simpson, masterylearningsystems.com. For Richard Stands. Well, I was doing a demonstration math lesson one morning in an elementary school when I heard these words come over the PA system. A third grader had been chosen to lead the school in repeating the pledge to the flag over the PA system. I had to chuckle when he solemnly intoned, "And to the Republic for Richard stands." It also struck me that none of the children around me seemed to notice anything unusual about what he said. What are these kids thinking? I mused. Do they ever stop and wonder who this guy Richard is? And why is he standing? And what about all the kids who say words every day like allegiance, republic, and indivisible, and liberty, but have no idea what these words actually mean? These are perfect examples of the fake it till you make it aspect of rote memorization. Kids repeat the words in unison over and over again until they can finally say them right. At the beginning of the rote memorization process, they mispronounce many words, and they don't know the meaning of many of those words that they're mispronouncing. As the children continue repeating the words day after day, eventually the words sound like they should, but some of the words still lack meaning. And that's why we have third graders repeating such nonsense as, "And to the Republic for Richard stands." For some pupils, the essence of the experience of saying the pledge is just saying a string of words that sounds right. They are not using their words to make a meaningful statement. And the words that lack meaning to them cannot be employed by the students in contexts other than repeating the pledge to the flag. Well, the same thing often happens with rote memorization of math facts. Students practice saying their sevens, for example, until they've memorized a string of words that sounds just right. But for some students, that string of words has no mathematical meaning. So they don't have an intuitive sense of how to apply their, quote, knowledge of the math facts to solve even simple mathematical problems. Here's a case in point. While I was visiting my friend Mike and telling him about my new book on multiplication, he suddenly got all excited and called for his son Spencer to enter the room. He wanted to show off how well Spencer had memorized his times tables. Spencer was impressively quick. Mike would call out a verbal cue like 9 times 5, and Spencer would immediately answer with 45. Mike gave him several rapid-fire cues, and Spencer nailed every one of them, until Mike called out 6 times 7, and Spencer answered with a number that was not 42. Mike apparently thought he could elicit the proper reaction by giving the same verbal cue, but more emphatically. So he called out, "No, Spencer, 6 times 7. Spencer answered incorrectly again with a wild guess. It wasn't even close to 42. After several more exhortations to think, Spencer, and more wild, crazy guesses, Mike realized that Spencer was not thinking mathematically at all. So Mike gave him a hint. Use what you know to figure it out. You know what 5 times 7 is, don't you? 35, was the immediate reply. And you know what 7 times 7 is, right? 49, was his instant answer. So 6 times 7 must be 108, was Spencer's meek attempt at finding the word that sounded right in this situation. Clearly, Spencer was not thinking of multiplication as repeated addition, or he would have added 7 to 35 to solve the problem. His efforts were focused on what sounded right, not on what made mathematical sense. He was involved in a linguistic model of memorization rather than being engaged in a mathematical model of remembering. Now, compare this case to that of Robin, a 6th grade girl who was asked to count the number of objects in a pictured array, kind of like the one you see here. She started counting the objects one by one, 1, 2, 3, 4, 5, 6, but soon noticed that they were arranged in groups of 5. So she started counting the objects again from the beginning, 5, 10, 15, 20, 22, 24, 26, 28. She then looked up at me with a smile of satisfaction, heedless of the fact that she had just switched from counting by 5s to counting by 2s. Well, wanting to help her discover and correct her own mistake, I repeated her own words to her. I said, Robin, you said 5, 10, 15, 20, 22, 24, 26, 28. She looked at me knowingly and smiled radiantly with a look of, I'm pretty good at this, right? I had thought that I was appealing to her mathematical mind, and that she would recognize that what she said did not make any mathematical sense. But without intending to, I had actually tapped into her linguistic mind, and she was satisfied that her words sounded just right. In a similar situation, a middle school boy had counted the same objects like this: 5, 10, 15, 20, 30, 40, 50, 60. He had inadvertently switched from chanting by 5s to chanting by 10s. He was chanting by 5s, not counting by 5s. His words were actually describing a picture like this, a bunch of groups of 5 and then groups of 10. And he too did not realize his mistake when his numbers were repeated aloud to him. Both he and Robin had tripped up on the same language-oriented issue, which is, what word sounds right after 20? Now, consider the experience of Jaime, a 7th grader who wanted to show how fast he could count by 2s, to up to 24. He began enthusiastically. Okay, ready? Go. 2, 4, 6, 8, 10, 11, no. 12? No. 13? No. Baffled and embarrassed, he determined to try again. Okay, go. 2, 4, 6, 8, 10, 11, no. 13, no. 12, no. But he didn't give up yet. The third time, he said the words he knew as fast as he could, hoping the other words would just tumble out of his mouth on their own if he got going fast enough. It was as if he were trying to ride a bike up a steep hill and could only make it to the top if he got a good running head start. A few more attempts yielded the same result every time. He never did get past 10 and eventually gave up. It turns out he had no idea where the words 2, 4, 6, 8, 10 came from in the first place. He did not have a picture in his mind of objects arranged in groups of 2 which could be counted. For Jaime, counting had nothing to do with it. He was actually not skip counting by 2s, he was skip chanting. As we have seen with the pledge to the flag example, rote memory can be completely unconnected to any sense of meaning. Memorizing musical words, or math words set to music, can be quite charming and engaging, although equally nonsensical. For example, just think of all the American school children who can sing Frère Jacques in French without knowing the meaning of the words. You know, Frère Jacques, dormez-vous, sonnez les matins, and so on. Or how many Beatles fans could sing the words of Michel in French? Michel, ma belle, sont des mots qui vont très bien ensemble, without understanding them. they cannot use the individual words in any context outside of singing the song. Rote memory is related to what I call instantaneous verbal mimicry. I once saw this remarkable ability displayed by a group of kindergartners. Their music teacher had told them to listen quietly while he sang them a new song. To his surprise, they started singing the new song right along with him, even though they had never heard it before. As the words of the song rolled out of the teacher's mouth, they also came out of the children's mouths. Somehow, those little 5-year-olds were able to instantaneously imitate both the words and the tune of the new song. Does that mean they understood the words? No, not necessarily. Just as reading comprehension does not automatically follow accurate decoding, the universal talent for linguistic mimicry and rote memorization does not always connect to the mental realms of curiosity and meaning and understanding. To be blunt, just because you can say it does not mean that you understand it. And just because you can do something does not mean that you understand it either. Children are nearly as good at physical imitation as they are at verbal imitation. So if you're having your class practice counting aloud by 4s, for example, you should be aware of what might be happening and what is really happening. If there is one child in the class that truly understands counting by 4s, all the other students in the class can successfully count by 4s just by imitating that one child. Now, what if the whole class truly understands counting by 4s? But the speed at which the class is counting aloud together is too fast. Some of those students will stop thinking mathematically and will unconsciously revert to verbal imitation. And they will be skip chanting instead of skip counting. Now, if you are engaging your whole class in a physical activity while practicing skip counting, for example, stepping together in time, counting aloud by 3s, and clapping on every 3rd step, like this. 3, 6, 9, 12, and so on. Watch for signs that individual students are imitating their classmates physically or verbally rather than thinking mathematically. If a student is out of step with the others, or is clapping a little too late, or is mumbling the words, that student is probably not experiencing the threeness that he should be experiencing. The internal experience of that student is more likely to be, okay, now keep on walking, clap when the others clap, and say what they say. Help that student individually to master the combined skills, a little bit at a time. First, walking and counting, saying every 3rd number in a loud voice. Then practice counting and clapping. Then put them together, walking, counting, and clapping. There is one surefire way to guarantee that students are not merely imitating their classmates and skip chanting rather than skip counting, and that is to avoid group practice. Okay, here's an example of a skip counting lesson that does provide individual students with authentic mathematical practice. Create a picture of numbered objects like this array of pea pods with 5 peas in each pod, like the one you see. By the way, this graphic appears on page 69 of my book on adding and subtracting, which you can buy on our website. It's masterylearningsystems.com. And it also appears on Chapter 3, page 6 of my book, The Best Stuff for Multiplying and Dividing, which you can also buy on our website, masterylearningsystems.com. So, give the student a copy of the page. Step 1. Have him or her touch and count aloud all the P's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on until they've all been counted. Step number 2. Have her touch each P and whisper say. Here's how you do that. You whisper the first 4 numbers in each pod, and then say the 5th number in a loud voice, like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and so on. Step number 3. Have him move his lips rather than whispering. Move his lips for the first 4 numbers in each pod, and say the 5th number in a loud voice while touching all the P's. 5, 10, and so on. Step number 4. Now, instead of whispering or moving the lips, have her think the first 4 numbers in each pod and say the 5th number in a loud voice while touching all of the individual P's. 5, and so on. Step number 5. Then have him swipe his finger across each pod, saying the 5th number aloud. 5, 10, 15, and so on. Step number 6. Give her a copy of the P-pod page that has no numbers on it, and have her swipe her finger across each pod, just like in the last step, saying the 5th number aloud. 5, 10, and so on. Voila! The student is really skip counting, not just skip chanting. If the student forgets a number, she doesn't need to make wild guesses based on what sounds right, and doesn't need to imitate someone else's voice. She owns an effective counting strategy that gives her independence. Lots of students have used this approach and found it to be very helpful. Here's a lesson on counting by 4s that uses a similar approach, but with some differences. Start by creating a picture of numbered objects like this array of dollars and quarters, and give a copy to the student. By the way, this graphic appears on Chapter 5, page 2 of my book, The Best Stuff for Multiplying and Dividing, which you can buy on our website, masterylearningsystems.com. So, have the student use a blank piece of paper to cover all but the first dollar, and the quarters, of course. Say to the student, touch and count the quarters. The kid goes, 1, 2, 3, 4. Good. Now, swipe your finger down the set of quarters that you just counted. Show them what you mean. And say, 4, summarizing what you've counted so far. The kid does it. Okay, now move the blank paper to show $2 and the quarters. Swipe your finger down the first set of quarters and say 4, then continue counting the next quarters, 5, 6, 7, 8. Good. Swipe the first set of quarters and say 4. Swipe the second set of quarters and say 8, summarizing what you've counted so far. Okay, now move the blank paper to show $3. Swipe the first set of quarters and say 4. Swipe the second set and say 8. Then continue counting the next quarters, 9, 10, 11, 12. When the student has the idea, have her continue alternately skip counting and counting on by herself. Then watch and listen. When the student miscounts or forgets a number previously counted, have him go back as far as necessary and recount. As in the other lesson, the students are now remembering numbers that they have previously counted, not memorizing a string of words that sounds right. They are, ta-da, skip counting and not skip chanting. Now there's a lot more to say about skip counting, but this is enough for now. Please share these ideas with other people that can benefit from them. And thanks for watching.